Hi guys and welcome back. In this video we're going to learn about default values for parameters. Let's say you've got a function called add and it takes two numbers x and y and calculates a total and then returns it. Then let's say we call it with the values 5 and 10 and print it out. So if we run this you get 15 because 5 gets assigned to x, 10 gets assigned to y, and then the sum 15 gets assigned to the variable total, the value of the variable is returned, and then that value is printed out. In Python, you can say y equal 3, for example, and what that means is that if you don't pass in this second value, then it will be 3 by default, so you can call this function with a single value if you prefer. So you can say add and just pass in 5 inside the brackets, and then y, because it doesn't have a value, will take the value of 3. So if we run this, you'll get 8. Notice that you can still pass in a value if you want, and that just means that y will be this value, and it will not take the default value. Also, let's take this opportunity to talk about named arguments. In Python, to make calling the function a bit more readable, you can say x equal 3 when you're calling the function. And what this says is x, this parameter here, will take the value 3. Y will still take the value 3 because that's the default value. If you run this, you'll see that the value is 6. You can say something like x equals 5 and y equals 2, and that's also totally fine. Now the result will be 7. And again, what this says is the parameter x has the value 5, the parameter y will take the value 2. Notice that this here is something we're doing when we call the function, so when we use it. And this here is something we do when we define the function. These are called named arguments, and they are there so that when you call a function, it's clearer what each number is for. So here the 5 is for x, the 2 is for y. But when you define a function, y equal 3 means a default parameter. So if you don't pass a value, y will be 3. Even though the syntax is the same, y equal 3 and y equal 2, they do mean slightly different things depending on where you use them. Something important to remember is that you cannot do this. If you do x equal 5, comma 2, you'll get an error. And that's because the argument that doesn't have a name cannot be used after an argument that has a name. So if the first argument has a name, such as x, then all subsequent arguments also must have a name. Otherwise, it will give you the error. The opposite can be done though. The first argument can not have a name and the second one can have a name, and this is fine. So it just means that if the first one has a name, the second one needs to have a name too. But if the first one doesn't have a name, the second one can still have one. So that applies for all the arguments. Similarly, if you just do y equal 2, Python knows that you want the value 2 to go to the parameter y. So instead of 3, which is the default value, we will use 2. That's all well and good, but we don't have a value for x. So Python will give you an error telling you that you are missing one required positional argument. A positional argument is just an argument that doesn't have a name. So here we have a named argument, also called keyword argument, and the x is a positional argument if we do something like 5. So you do need to provide a value for x because it doesn't have a default value. The same thing applies when defining a function, by the way. So you cannot have x equal 5 comma y because you've got a default value here but not here. Default values must go at the end. So if one parameter has a default value, all subsequent parameters must have default values as well. So this would also give you an error because it says non-default argument follows default argument. Many functions in Python have these named or keyword arguments. For example, the print function. Say you print 1, 2, 3, 4, and 5. What we're doing here is we're passing the value 1 to the print function, and then we're passing the value 2 to the print function, and then 3, and then 4, and then 5. So we're passing 5 different arguments to the print function. If we run this, you'll see that you get them printed out with a space in between each. But you can actually pass a special argument called sep and make it equal to whatever string you want, and then instead of the space, it will use that separator. That's what sep stands for. So here's an example of one of the built-in functions, print, that has one of these named arguments that you can use as well. If you have a variable such as default y and you want to create a function that uses it as one of its default values, this is highly discouraged. Here's this function which has a parameter x and a parameter y with a default value of the value of default y. What this does is when Python reaches line 3 and it defines the function, it remembers the name of the function, add, and then it also calculates the default value, which is at this point in time 3. So if you do add 2, that means that x will take the value 2 and y will take the value 3. If we run this, you'll see that 5 is printed out. But if you now change default y to say 4, and then you add 2 again, you'll see that 5 gets printed out again. So what this tells us is that when Python defines the function, it also stores the default value at the time. So even if you change the variable that is the default value, it will not change when you use the function. It still keeps the value that was used when you defined the function initially. Therefore, it is highly discouraged to use variables as default values because of this thing. The fact that you use the variable doesn't mean that this value is going to change whenever you change the variable. I'll say at this point, be careful when using lists or dictionaries as default parameter values. That's because unlike strings and integers, these will update if you change them inside the functions. And this is due to a language feature called mutability. It's not important for you to understand this now, but just bear in mind that lists and dictionaries behave differently than strings and integers behind the scenes. That's it for this video. Hope you've learned something, and I'll see you in the next one.